Hello, and welcome to this panel discussion about the differences among industrial robots. It's part of our Realizing the Potential of Industrial Robots series, sponsored by Rockwell Automation. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Realizing the Potential of Industrial Robots series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look at the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I'd like to pass things along to Edgar to lead us through today's discussion on the differences among industrial robots. So Edgar, welcome to today's event.
Thank you for the introduction, Katie. I am Edgar Sauter, Senior Director of New Product Technology at the CSA Group, and I will be moderating this panel today. We all know how robotics is changing the manufacturing industry and other areas as well. But how to pick the right robot for each application? That is the topic that we will cover in this panel discussion today. And we have gathered an excellent group of experts to discuss this topic. With us today, we have Aaron Plattner, who is the Director of Robotics and Autonomous Systems for ASTM International, where he oversees standards development, training and workforce development efforts, and R&D funding. Aaron has written numerous articles about robotics and their role and impact on workforce development. He is on numerous boards and committees that develop a curriculum for robotic training. We also have with us Justin Garsky. He is the OEM segment lead for robotics for Rockwell Automation. For over 20 years, Justin has been connected with robotics, independent cart, and automation, spending time in field service, engineering, and then sales. He has continued to gain knowledge and industry experience in a wide variety of applications. We also have with us Dean Phillips, who brings 34 years of manufacturing experience to this panel. He is an advisor to SMEs Smart Manufacturing Advisory Committee. He is also an accomplished speaker in IoT, AI, robotics, and AR and VR. He is also an entrepreneur and has served on the board of directors as an advisor for multiple technical committees. We also have with us Brian Gard-Davis, who is a consulting engineer and roboticist with experience in various industries and applications. He has hands-on experience developing and deploying robotic arms, mobile robots, cobots, and more, along with a master's degree in mechatronics from the Stellenbosch University. So Dean, Aaron, Brian, and Justin, thank you very much for being here today, sharing your knowledge and experience with our audience. So as I mentioned before, robotics is changing manufacturing. But as a company, as an industrial organization that wants to implement robotics, there is always a challenge to know what type of robot should I pick for my application. Are the all robots the same? How should I look for the different robot that I need? So we will cover that topic today. But before we start, let's acknowledge our series sponsor. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's inherited expertise in industrial network, sensing technologies, and digital software means it is one of the preeminent authorities for everything related to smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So without further delay, let's start with our panel discussion today. And I would like to start, as we start many of our panels, with a very generic question. So we will be talking today about industrial robots specifically, and let's try to define what makes industrial robots special. Like, what is the difference between an industrial robot and my little Roomba robot that I have here at home cleaning the house? So, Brian, I think we discussed this before we start the panel. So if you could please help us with that question.
Yeah, sure. I think what it really comes down to is programmability. So these consumer robots, they typically work out of the box. They don't require any sort of expertise to get up and running. You know, you unbox it, you select maybe a mode, you maybe have one or two or more modes that you can select, and it'll be, up and running. Whereas industrial robots, like typically robot arms or AGVs or AMRs, so autonomous mobile robots, they require extensive programming to get up and running for their specific application. Additionally to programmability, of course, industrial robots are way more accurate. They're more rugged. They can be expected to run far longer hours before needing any kind of replacing or maintenance. And of course, they tend to cost 10 or even 100 times the price of consumer robots.
Thank you, Brian. So now that we have defined what an industrial robot is and those particular differences, let's talk about the type of industrial robots that we have. So if I am a manufacturer, what are all those types, or even if you have some sort of classification of them, this would be a good time to kind of educate our audience on that. So who in the panel would like to make a comment on that, on the type of robots that we have, industrial ones?
Yeah, I could carry on there, Edgar. So typically in industry, there's two types that are really prevalent, and that's robot arms. So that's sort of your a robot with about 6 axes, sometimes 7. That'll have an end effector, which is like a tool. So it might either be a gripper or a welding tool, for example. And this robot would have its base fixed, and with the tool on the end, it is able to, for example, pick and place an item or perform some other kind of task like welding or painting. The other type is, as I mentioned, the AGV. So that's the autonomous guided vehicle, or AMR, which is autonomous mobile robot, which is just a base with 2 wheels. And this robot is then able to drive around, let's say, a factory or a warehouse, moving parts from one side to the other. We're actually seeing now even these 2 robots being combined quite a lot now. So you'd see a robot arm mounted onto a mobile-based robot, and that, of course, opens up a whole new, avenue for various applications. These, I would say, these two are far and out the most prevalent. We do sometimes see these Delta type robots, which is sort of has multiple links in parallel, and these are normally the really fastest, sort of ultra fast robots for kind of pick and place applications. But I would say these types, so the mobile base, the ARM, and the gantry type Delta type are the most common.
Thank you, Brian. Now, with all this variety of robots, if I am a manufacturer, what are those considerations that I have to have in mind to pick the right robot? And Dean, I think we might have talked about that. Like, what are those first steps that I have to consider when I am trying to pick to select a robot?
Yeah, I think when we look at a robot, the first thing is the process. What is it that we want the robot to perform? Do we want the robot to be performing the action meaning doing something like a robotic welder, or do we want it to be the manipulator, where you may have a welder still, but you're moving the part using the robot? So understanding the process and the range of motion that's required, that's important in order to make sure you have the right size robot and the right aspect and the room for it. Sometimes people get a robot, and I've seen it before, where they run into a wall because they didn't understand the range of motion. Then you have, of course, the next aspect of it is the part itself. How big is it and what's the weight? Because you need to make sure that that part can be held by the robot. Then, of course, the gripper and end effector that you're using. How can it grip the part, and what does that look like? And of course, volume. How many of these am I going to have to do? Because some of the lower end models can't handle doing thousands and thousands of parts. They may not be able to withstand some of the expectations that we have. And then lastly, integration is really critical and probably one of the most overlooked areas. Some people just think I can buy a robot and I'm just going to put it in my factory, and do not take into account the safety aspects that have to be integrated from the robot to the piece of equipment that you're also working with. There's a lot of other aspects that have to be thought of, and it's best to do it on the front end, because when you have to respond to it after, big problems.
Yeah, I saw some people nodding a lot when you mentioned integration. I bet people have some experiences with that. And actually, Justin, I see you. Do you have any comment about the integration portion?
Yeah, I mean, all of that, right? So we talk a lot about what we would consider unified control. So that's controlling it out of a PLC. Everyone, all the big brands have their own robot controller, but kind of that where the rubber meets the road is huge. And I giggle a little bit because I see them on LinkedIn all the time where it's a robot and it's just, it stops at every point and it, frankly, it looks like amateur hour, right? And there's a right and a wrong way to doing some of this stuff. And I encourage everybody who's learning and trying to upskill, but man, some of this stuff needs a little work and it's expertise, right? And so I think, Dean, you nailed it, right? Integration is super important and finding the right partner.
Thank you, Justin. Now, once I have identified that robot, if I am a factory owner, I would like to assess also like the value that I can take out of that robot. So can you talk, and I think, Aaron, you mentioned that in the conversation. Can you please talk about what are those, I would call them key performance indicators. I don't know if you have any other way to call them, that as a manufacturer, I have to look into to make sure that this machine, this robot is actually, I'm getting value out of it.
Yep. Yeah, I mean, absolutely, Edgar. I mean, it is a process. And as Dean pointed out, when you're looking at installing a robot, it's very critical that you actually really plan out what is this robot going to be doing, what are the integration challenges, and what are also the safety challenges that you're going to face. So it's really very important for the end user, the person that's going to own the final application, to be working hand in hand with the integrator on what are all the key factors. And when you bring up the KPIs, what is that? Are you looking for speed or are you looking for precision? And depending on what your application is, you could go either way. If you're looking for speed, that's going to put you into a classification of robots that are going to be very much your traditional industrial robots from your traditional robot arm companies. And that speed, though, also creates safety issues that you're going to need to address. So what is your safety sensor array? Are you putting up fencing? Are you putting in entry doors? All of this stuff needs to be discussed, as Dean said, on the front end. The earlier you address this, the better it is. But the whole thing is you have to look at exactly what you said, Edgar. What is that final KPIs that you want to hit? Because that's going to drive a lot of those things. The faster you're going to go, the more safety you need to layer on. The more precision that you're going to go with, Then you're going to be looking at sensors and even the accuracy of the robots. Some robots are going to be more accurate than others, especially when it comes to welding or gluing applications where accuracy could be very important to your final product. So these are just numerous things to consider, because after the robot is installed and done, the integrator's out, and that is your system now. That is your application, Mr. End User. So you want to make sure you got it right the first time, as Dean said.
That's a great point. And actually, we'll touch later when we start talking about risk. But before we jump there, I would like us to talk about two type of robots that I have seen a trend lately of them going. One is cobots, the collaborative robots. And the other one are the mobile robots, most specifically the autonomous ones, because we already have AGVs, which kind of they go in a path, but there is, I believe, a trend about autonomous mobile robots. So how do they fit in today's industrial applications? Let's start with the cobots. And these two questions go to all of you. So whoever wants to jump in first, please feel free.
Well, I'll go ahead and do the first swing at this one. When you're looking at, again, going back to what we talked about earlier, your application, what are you trying to accomplish? If you have what is a collaborative type of application where the person and the robot are going to be interacting on a regular basis, then you should start looking at the cobot side of the equation. Now, the question will be, though, how much collaboration's really going on? Because what we're actually starting to see, and there's been some studies in this area, is that a lot of cobots are not being put into collaborative applications. They're just being put into applications where the people didn't want to put a fence around the robot. That is your call, but is that what you're going to give up on a cobot is the speed, okay? Because that's how they're safe. They go slower than an industrial traditional robot. So you need to sort of consider all those things, because a cobot versus an industrial robot, there is a price difference. There is a big price difference. So are you really matching your funds and ROI to the right robot? Because if you're going to go buy a cobot but then not put in a collaborative application, you probably wasted a lot of money and changed your ROI calculations tremendously. If you are doing a collaborative application, then really look at those cobots, because those are going to save you time, money, and a lot of headaches.
Got it. Anyone else wants to jump in?
I was going to say, I'm going to add a little bit to that, Aaron, and I think you've seen more of these than I have, but I've heard the stories around, when people are, I would say, misapplying a cobot, they're working out on the very, very end of the reach of the work envelope. It's overloaded to the max payload. And now, in addition to having something really expensive because it's misapplied, you're wearing it out faster. You're trying to run it faster than it was hoping to run. Like there's kind of that perfect storm where, like you say, if you don't need to, probably not the best solution, but they are great, right? I've seen the applications where people are, interacting with the part that's in the end effector, doing the fine detail work that there's really no other way to do today without, crazy AI and other stuff. It's great, but a lot of misapplication for sure.
Got it. So when it comes to cobots and industrial robots like ARMS, when would you suggest if you can give some examples of what applications are better for the industrial ones and which ones are better for the cobot? I think, Aaron, you touched a little bit about the speed versus
yeah.
Yeah.
I mean, I think Justin brings up a very interesting point, because also one of the things he mentioned is what is the object that you're handling? That's part of your application, is the actual piece that the robot's going to touch. So if that's a box, you have to account for, okay, what is the best robot to handle this box? Okay, as Justin brought up, weight is a consideration. Most cobots can't lift much more than, I think the top one now is about 20 kilograms is the biggest cobot that can handle weight. So if what you're trying to handle is more than that, you might want to look you're going to probably have to go to the industrial side anyway. But then also, let's say you're handling small things. Okay, good. This might be a great application for a cobot. Oh, it's razor blades. It's knives. Okay, that's not a safe end piece that you might want to be working around people. So again, it's how is your application from not just the robotic arm, but what's your end effector? A welding piece, is that truly a collaborative application? I mean, it's really going to be up to what that company is trying to do in that application. And then what is the actual final part? That's part of your application. So again, all of these add up. I would say collaborative applications like Justin described, where maybe you need the robot to hold the part while the person works on something, or you need the robot to bring something into the person's work area so that they can then work on it, but that's a safe movement from as it's entering the worker's safety envelope. But if you're not doing that, if you're just palletizing 50-pound boxes, go with your traditional robot and call it a day. I mean, that's really what it's going to come down to. So I would just say for folks looking at these types of robots, you got to look at your application first. Look at your application first, then start figuring out what you need.
Good point. Now, you also touched about risk, and I wanted to jump to RMAs, but this is, I believe, a good point also to ask a question about risk. When you compare traditional with the cobots, what is the difference between the complexity of assessing risk with the traditional one to cobots?
Well, I mean, right now there is the ISO risk assessment, which has been adopted by ANSI here in the United States. So that's definitely where you're going to start, is on your risk assessment, where you walk through everything. But it is going to be very similar to what we just talked about, breaking down every part of the application from the arm to the end effector to the end piece. Each one of those adds risk to the equation. And it's what do you then need to do to mitigate it? I can go get a collaborative robot, pull it out of the box, install it, and it will operate safely. But then when I start putting the end effector on, okay, how's that now changed the risk to it? Where is that robot going to operate in context to the human? If the human is part of the equation, okay? If the human's not going to be part of the equation, then you got to look at it differently. You might just be doing a cage to keep people out of the application. But if you're looking at a collaborative application, you really start breaking down of how is this interacting with the person? Where are the certain parts? Is the robot coming in close to my head? I mean, that is something you have to consider. Or is it coming in low? There are actually, in the ISO and ANSI risk assessments, if you're going to do a cobot, there is actually a section that actually says, are you going to come in contact with the human hands? And there's tests of how much maximum pressure the robot can apply, just in case there is a contact with the human hand, because that could be an injury. Same thing. There literally is a study on every body part in the risk assessment of what the maximum forces you're going to be allowed in your risk assessment. The very interesting thing is in there's not many things for the head, because you should probably never make contact with the human head. So those are the kinds of things, though, you have to consider. It's not as simple as folks say, just go buy a robot and install it. No, you have to think this through. And I'll close with this very last thing. If something bad happens with your robot and a person, regardless if it's industrial or collaborative, there's going to be this entity called OSHA that's going to show up. The first thing out of their mouth is, where is your risk assessment?
Right.
They're going to ask that question first, because they're going to see, did you do a thorough risk assessment for the application? And I will say that OSHA inspectors are being trained on robot safety standards. So it is very important to end users alike, from the manufacturers to the integrators to the end users. Everyone knows their risk assessments for their part of the equation.
Right, perfect. Thank you very much, Aaron. Now, before we move to the people side of the equation, I would like to cover the autonomous mobile robots. The question is, when is appropriate to use them, and why to use them and not just a conveyor belt or an AGV? So if I don't know, Brian or Dean, could you please help us with that question? That would be fantastic.
Yeah, sure.
Go ahead, Brian.
Yeah, thanks. Okay, thanks. So the mobile robot is, it's able to, first of all, create a sort of map of its environment. So if it's a warehouse, it'll be aware of sort of the aisles in the warehouse, and it's able to then move apart from one side of the warehouse to another. Most of them are also equipped with sensors like LiDAR sensor or sonar, ultrasound sensors, so that they can also avoid bumping into people. So they have this sort of obstacle avoidance built into them. Also just on this topic of safety, they also tend to have sort of bumpers. So bumpers that are kind of like it's a button, essentially a button in the form of a bumper, that as soon as that bumps into something, it would then, cut the power to the motors. So that's another safety aspect of AMRs. But compared to conveyor belts, of course, they're way more flexible. They're not just moving things in a straight line. You can really take things essentially anywhere in the factory, whilst at the same time, avoiding obstacles. And they can, from having also this map of the environment, you can really easily kind of give goal coordinates, so sort of X, Y goal coordinates to the robot, and then it will, drive from A to B.
Perfect. Thank you, Brian. Dean? I echo all the things that Brian had mentioned. There's no question that they're being designed better to protect, because there's a common environment here. For example, companies like Bridgestone, they had where they're moving tires, and part of their range of motion is that if you're standing in front of it, it will wait or it will move around you, but it will also, as you're traveling, it will travel and can move at the same rate of speed, and it can understand those types of things. The other aspect is to understand not only the robot's area, but also understand the greater peripheral of the part that it's carrying. So in this case, it's carrying tires, so it understands the greater area that it's covering, and it's using vision systems in a lot of cases also. So that's one of the things that are really interesting and where we're going with some of these possibilities. And they're getting better every day because we have greater sensors. The sensors are just really taking off, and how we can use them for vision systems, and then mapping based on coordinated vision systems. It's a great time to be in robotics, I will say that.
Sounds great. Now, Justin, you mentioned before a good topic about integration. I remember when we were doing that comment before. And I'd like to ask you that question to you, Justin, and please anyone else, like of the other three, if you want to jump in, that I appreciate that. When it comes to these more autonomous systems, how easy is to integrate those systems to the rest of the factory? That they present a challenge, or is it just easier than the standard ones?
So I think it depends a lot around which system you're looking at and where it's coming from and what your hopes and goals are, right? So there's people out there that have, in similar to a warehouse system, right? There's a WMS, there's a fleet management system that comes along with a lot of these. So the question then becomes, is it a simple, repetitive, I need to go from A to B and I'm just finding a route, or is there a really big scheduling system that's integrated within your MES or ERP system, right? So it can be all over the board. I would say a lot of the people that are selling them, whether it be the vendors themselves or the integrators, they've got the tool sets and skill sets to do this, and it's getting easier nonstop, right? We have a consulting team that does that as well. But there is some assembly required, right? They don't just show up and automatically know how to talk to, your iPhone or anything else, right? You have to do the work to get it to talk to those systems.
Perfect. Now, and with all these things of AI, is AI like playing any role today in robots?
I'm going to let somebody else answer that question. I haven't seen a ton of it myself, but my corner of the world's a lot in the CPG space where it hasn't been.
And these questions has came in the other panels of this series, but for the people that have seen only this one, that would be fantastic if any of you can make a comment on that.
I can chime in here. When it comes to the AI, there are a lot of systems out there now that are standalone kind of AI systems, which can do analysis of motor drive systems, torque, things like that. So it can analyze any system and understand what's going on and make comparisons of where is this trending? Is it getting worse and taking more current, or is it getting better? And you start with a baseline and you can improve upon that. But I think that right now, AI is starting to be integrated in more and more of these systems. In the long run, I can't imagine a single system not having some form of AI taking into account what's happening and building these neuro systems internally of, yeah, I was taking this into account, but I also need to take this, and this also into account, so that I'm getting a greater picture. Therefore, I can build the best possible solution.
Perfect. Thank you, Dean. So we have talked about the robots, the type of robots, the considerations that the manufacturers must know to kind of select the proper one. We have touched risk as well. I'm pretty sure this risk involves some sort of functional safety to make sure that the robot kind of meets follows the standards. Let's talk now about the people. If I am a manufacturer, I buy my robot, what considerations should I follow with my employees? What type of training, or let's start with the safety kind of training. Like, what would you suggest them to do?
Well, my suggestion on this would be, as we talked about earlier, of you want to be hand in hand with your integrator to make sure you design the right application. I would actually say your employees should be part of that conversation as well, so that they can not only explain what the task is that might be being automated and some of the nuance there, but at that time they can also ask questions back to the integrator of what is the safety aspects I should be aware of and concerned about, because that robot, that employee is probably going to be working with that robot more than anyone else on the floor. So it's going to be very important to get them involved right away, because then they can ask those questions about safety and put their mind at ease, but also they can start learning of, okay, what do I need to learn as an employee of how am I going to have to operate this robot? Is it just going to be as simple of I just push this button and I reset, and this is my go button, this is my reset button? Or do I got to actually hold on to the teach pendant and actually understand that? So again, this is stuff that should be discussed as the application is actually being built. You should have two parallel tracks. As the integrators installing the robot, your employees are being trained and learning the safety aspects of it as well. Again, if you're doing all this together, you're going to come up with a better application at the end that's going to make not only you happy as the business owner, but your employees are going to have an ownership stake from day one. They were involved in the process.
Thank you, Aaron. What about the training? Like, do my employees have to retrain in how to work around it, how to actually interact with the robot? Like a skill I'm talking about. Go ahead, Brian.
Yeah. I was going to say certainly retraining is possible. A lot of these robots, if you have employees that have even a basic background in, for example, programming, you can normally learn how to program the robot by being trained. Similarly with if you have mechanical engineers, they could easily learn. And let's say they haven't worked with robots before, it's quite quick to learn how to, create tooling for the robot with minimal amount of retraining. But I think, in terms of this, on the safety side, I think Aaron really covered everything pretty well. I mean, what I've seen a lot nowadays, of course, is with the teach pennant, where you actually have the so-called dead man switch. So that switch needs to be pressed just to be able to do anything. And the moment you release that button, the system shuts down. So that's really a hard safety feature that's in addition to many emergency stops, placed all over the shop. At any moment, any other person in the factory should be able to reach, one of these e-stops. But I think retraining is certainly possible. I don't think it's always necessary to hire new staff, unless, of course, maybe you have no one who has any kind of familiarity with programming. You might want to hire someone on that side, but I think generally retraining is enough.
Thank you, Brian. Now, you touched a good point there on hiring someone that may know about programming. And Aaron touched a good point that after I have the robot up and running, after commissioning, I'm the one, as a manufacturer, I'm responsible for that. Is it worth to hire someone in-house that understands robotics and probably takes care of manage the robots on my floor? Or should I just keep the relationship with the integrator? Like, what would you suggest a factory owner to do?
I'll jump in here. Yeah, I think having some of that staff on site is super important, right? There will be things that pop up. Actually, that's how I got into this business. When my dad went from welder to robot welder. So 35 years ago, we learned no programming experience, picked it up. But being able to do that maintenance, being able to touch things up, even if it's having an awareness. So when you call the other people, the experts, the integrators on the phone, at least you're speaking a common language. You don't have to know everything about everything, but having somebody on site that knows how to move it, how to get it out of a jam, super important. Yeah.
Thank you, Justin. Brian, you were going to say something about that?
No, I think Justin covered those points really well. Yeah. I mean, it's, as Justin said, having someone on site who can speak, a common language with the suppliers. You don't always want to have to call someone in, especially it's often something pretty simple. Sometimes it's just a reboot. You just need to power everything down and power it back up again. So, having people on the floor who are familiar with it, of course, is a huge advantage. And it's certainly possible, it's certainly possible these people can, gain that knowledge and the expertise.
Yeah, and I would add to Justin's point that what we're actually starting to see from a lot of these firms now is ongoing support. So that is actually probably something that should be part of your equation of not just pick the right robot, but pick a service plan, an ongoing support plan, if it's available to you, that makes the most sense. So this is again another thing, as Justin pointed out, was if you assess your workforce and you realize maybe there is a gap that you might not be able to address on the training or maintenance side, ask the OEM or your integrator, is that an ongoing service they offer? Some of them do offer it, some of them don't, but that's a way you could also address some of the training issues, is just what is the support level that you might need. And now with a lot of companies going to this robot as a service, some of that's actually baked in now to that, especially on the mobile robot side. It seems that's to be a very common thing of, oh, my mobile robot's not working right now. You can call up somebody, they can assess it real fast. And if they say, hey, it's broken, ship it back to us and we're going to ship you a new one right away. That's actually an option now that has popped up in the last couple of years. So again, something for as an end user to consider when you're looking at these things. It's not just the hardware now. You have service plans available to you.
Thank you, Aaron. So a quick question. Is this only accessible for big manufacturers? So if I am a medium, small size manufacturer, like what options do I have?
Yeah, I mean, I think the area where the most growth is expected to be seen is in small and medium-sized manufacturers. I think in the past where, you'd only really see really large companies that would have these, sort of giant robot arms that are just pumping up thousands of parts for months on end. We're now seeing small and mid-sized manufacturers start to adopt robotics, especially cobots. I mean, I know cobots took a bit of a hit here from the panelists earlier, and I agree with a lot of those points. But one thing that cobots can claim is this so-called ease of programmability. So they have this teach option where there's kind of like either a gyro or some kind of IMU sensor in the end of the robot that you could just grab, move it around, move it in the path that you would like it to perform, and then capture that, record that, and then you can replay that. And I think that, and what comes with that is the flexibility. I think the small and mid-sized manufacturers want flexibility. They might just do one task for just a day or two, and then suddenly they're changing a part or they're changing the application slightly. And of course, they want to be able to just do that themselves, right? Set up a new program. So I think there's a huge amount of growth that's going to come for small and medium-sized manufacturers.
Thank you, Brian. Well, time is almost over. We have 5 minutes left, and I would like kind of to hear from you guys. What do you think about how the factory floor is going to look like from the point of view of robotics and their implementation 10 years from now? Like, what do you see? And I would like to start with you, Dean. Like, what would be your vision about that?
Yeah, right off the bat, we're finding new applications for robots, and I think that's a great aspect that we hadn't looked at before. We said, here's the robot, here's what it does. Now it's, here's what the process is. How can we find a way to do it better, to do it safer? That's another aspect that we sometimes overlook, is that if we can remove somebody from putting their hands in an unsafe area, that reduces risk. That's really important. And I think those areas are going to continue to grow.
Perfect. Thank you, Dean. Aaron, what about you?
I think we're going to see more and more robots coming to bear across from the smallest of enterprises to the largest. And I really think, going back to Justin's point, I really think that you're going to start seeing smaller folks, companies having robots. And as Brian said, that's where the growth is going to be. So you might only have one or two CNC machines, but I see you're going to have a robot. You're going to have a cobot probably handling the parts in and out of that, because that's going to free up your folks to go do other things. And I think that's going to be the biggest key. I think we're going to start seeing folks understand which tasks exist across the industry that can be easily automated, and you're going to see businesses all go after those things. So machine tending is a great one to go after. Building pallets of boxes, that's another one. I mean, so the whole thing is, I think we're going to see the industry sort of just show application after application that can be automated. And if you have that task in your factory, there's going to be almost a roadmap of how to get you to that type of automation quickly.
Thank you, Aaron. Brian, your turn.
Yeah, I think all those points are really, really great. And I think I don't think we're going to ever see, sometimes you see these presentations and these videos online of these factories that are just filled with hundreds of robots and they're all working perfectly in sync. I don't think we're going to get to that point anytime too soon. I mean, anyone who's ever sort of dived into just software programming, for example, and how bugs can pop up. Imagine you have like 100 robots going around. Imagine how frustrating bugs would be, bugs in the system. So, I think we're always going to have humans on the factory floor. I think we're going to see definitely safety, as we've discussed in this panel. Safety is going to be really utmost. We're going to see, I think, advancements in sensors, especially things like capacitive skin sensors. So sensors where the robot is able to sense when a human is coming close to it without having to actually, make any kind of contact. And that might, with advancement in these sensors, we might not see this issue of speed and power being limited. As I think Aaron mentioned, when you have a human in the work envelope of the robot, of course you can't go too fast, you can't have too much power, but maybe we'll slowly start to see that speed factor and that payload factor start to increase a bit with the improvement in safety and sensors.
Thank you, Brian. Now, I know this is hard, Justin, because probably all the people have already said a lot of things. But last but not least, I would like to hear from you, Justin, what your thoughts are.
Yeah, I mean, I think Brian, your comment around, hey, it might not be tomorrow. I know it's coming, right? We're getting those requests, we're getting those asks. There's a lot of work that we have to do as an industry and as a community to bring that forward. But we're getting real life questions from CPGs that say, hey, we need to run lights out, right? I think back to 30 years ago, Bobcat could make a bucket for a skid loader without having a human involved, right? It dropped the parts onto an AGV, brought it to the work cell. They came down, they came up. We're seeing the things where robots are loading blanks into things like case packers and cartoners. It's coming. So I would say the biggest thing for me, not necessarily the time horizon, but I think we're at a point where a lot of manufacturers are going to have to adopt or just cease to exist, right? We can't find workforce. Workforce is a huge problem. So I think whoever solves the problem of how to get there soonest, they're going to come out ahead, right? So I agree with you guys. I think we're a little ways from there. But I think that's the arms race that's going on right now.
Thank you, Justin. So unfortunately, we have reached the end of the time that we have for the panel discussion. There is a lot of more topic to cover, but the time is up. So there will be another panel. We can do more further discussion. And for today, we have received a series of questions from our audience. So we want to pick up a few of them to answer them now today. The other questions will be answered either email or chat, well, depending on the method, but we will pick up some to answer today. So we'll be back in a few seconds, and back to you, Katie.
All right, gentlemen, thank you all for that great presentation. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can. If we do not have time for your question, do not worry. We will reach out to you following today's session. So Edgar, I'm going to pass things back to you and the group to answer some of our attendees' questions.
Thank you, Katie. So we're back with 3 questions that we picked from our audience today. The first question says, are there specialty needs for certain industries? For example, food and beverage or pharmaceutical? What robot technologies lend themselves there?
Interesting. I'll take that. I'll take a quick jab at that one. Actually, when you look at food and beverage and pharmaceuticals and some of these other special industries, actually the first thing, almost going back to our conversation of as you're building your application, you should be like building in that. I would say the first thing that the food and beverage and pharmaceutical ones is realize you're going to have even additional safety features of don't contaminate the food or the drugs. So what are you doing in that realm? And actually from a standards organization there are actually industry standards on health and safety of how you handle that product. So you need to ensure your robot can meet that. So like for food and beverage, the first thing that comes to mind is you have to be able to clean the robot on a regular basis. Almost daily, it's going to probably have to be sprayed down with some kind of cleaning agent. And so it has to be able to withstand that. So there are actually food-safe robot arms that are on the market that you would have to look at. So yeah, if you're in a very specialized industry, my first thing is look at actually the standards already in place for your industry, and can the robot meet those standards as well? So that would be the first place I would look.
Thank you, Aaron.
I'll add a little bit to that. I think the other one is kind of the temperature, right? So too hot, too cold. I've seen a lot of people put robots in freezers and then they wonder why they don't work. So I think you nailed it with the foaming and the wash down. Also, some of the chemical interactions, right? Are we going to corrode? Stainless versus painted? It is a wild thing, but definitely, like you said, just like safety, really take a good hard look at it and make sure what you're putting there fits for sure.
Thank you, Justin. A great answer, both of you. The next question that we have says, can manufacturers integrate robotics at a slow pace or in a phased approach? Or does the change need to be more holistic?
I'll take that one, if you don't mind there. It's a very good question. I think a lot of companies, especially small companies who are trying to dip their toes in the water and want to know, hey, I just want to see what I can do. On the cobot world, that's a little bit easier because the cobot has, in fact, it can even be robots as a service. There are more of those types of companies that are coming up where it's, okay, I am going to take a robot in for the next month, and it's for a pick and place operation, and that's fine. The aspect that where it starts to blur that line is when you start talking about integration and safety. If I'm integrating, I'll give you an example of where I see it a lot is on stamping environments and fabrication. When you start talking about manufacturing and you are having to integrate this robot for a manipulation process, or it's going to integrate with a line, there has to be integrated handshaking. Now, and for those that don't understand that, I have to confirm that something I'm telling you to stop, and I need to make sure that you're stopping back to me. There's also the aspect of who tells who to stop, so you don't get locked out, because if I tell you to stop and you're telling me to stop, guess what? Neither one of us can go again. How do you reset those kinds of things? And that's where a lot of the integration becomes really critical. And we talk a lot about integrator. To the average people that are getting involved in robots in a small side, they think I'm just going to go buy a robot, not understanding the factor that in what a integrator does. You think you're going to buy a robot, you got this machine here, I got this machine here. Well, they're just two different machines. You have to integrate those, whether you do it yourself or have somebody else do it. They have to talk. They have to have stop signals. What happens when you open a gate? Does that stop the robot? Does that stop the other machine? And in what sequence? So you have to understand all of those things. So I think you can dip your toe in the water and you can make a slow approach into it, but the safety is definitely an area you have to have a holistic philosophy. I'm going to do this and we're going to do it right.
Thank you very much, Dean. And the last question that we have from our audience today says, sometimes robots are characterized as smart. What does this mean? Are they intuitive, connected, self-controlling, something else, all of the above?
Yeah, I could try give that a go. So I don't think smart is really a standard industry term. I mean, I haven't come across it too much in terms of being sort of a standardized term, but I think I guess it's all of the above, really. I think it also depends a lot on what your own area is and how you might view it differently to someone else. I would say, sort of from the system architectural point of view, it means that the robot, it has all the intelligence it needs on board. You sometimes hear people speak about on the edge computing. So the robot, which has maybe a small sort of single board computer on it, it would have all the necessary intelligence as well as, of course, sensors, such that it could, for example, do obstacle avoidance and do mapping, instead of having to rely on sort of a central server. Of course, it would be communicating with the central server, but the robot itself, it is able to navigate and to avoid obstacles. So I would say it's self-controlling, that you have all this intelligence on the robot itself, and not the robot isn't always relying on communications from a central server.
Thank you, Brian. Well, that concludes our panel today. Dean, Aaron, Brian, and Justin, thanks again. Thank you for being here and sharing your time, knowledge, and experience with all of our audience. We had a really nice panel discussion. We also appreciate our audience to be here today and listen to the whole discussion. There's another panel session of this series, and we invite you to be there as well. We're also grateful to Rockwell and their staff of experts who are doing their part to bring smart manufacturing into reality each passing day. And finally, for globalspec.com, thank you to the millions of technical professionals engineers who have allowed us to connect them to the parts and services they need to project success. So, having said that, back to you, Katie.
And thank you, Edgar. Now, just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Realizing the Potential of Industrial Robots series. Today was session 3 of our 4-part series. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with all of us today. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or share it with colleagues. Again, thank you for taking time to attend this Global Spec Series event. Take care, and we will speak with you soon.